What is up, everybody? Tom McGurl here with another episode of our Learning Rust live stream. We're going to be continuing with exorcism.io. Getting a little late start here to the live stream. We usually start at 9. We're starting a little after 10 today, but it's going to be a little short episode. Again, we're going to be continuing with the Rust track of exorcism.io. So if you missed the previous episodes, do not worry. They are available to you. You can see them right over here on the YouTube. So we started this a few weeks ago. We did part 1. We're doing part 2. We're going through the syllabus. So there's a syllabus with different steps, and they actually added one in the middle. So we're going to retroactively go back, take care of that one, and then continue on. So should be pretty fun. Again, follow on Twitter for when I go live. Been trying to do it every week, but I'm on break right now for winter break. So I've been kind of taking it week by week. I'll continue uploading weekly, but the live stream I'm going to try to continue doing it every Tuesday, 9 to 11 p.m. So I'll try to stick with that. I'm not sure if I'm going to add a day as I originally thought, but we'll see. We'll see where it goes. It could be cool. All right. So today we're going to continue. You may notice we are doing the Rust syllabus on exorcism.io. Link to that will be in the notes. If you're on YouTube, it'll be in the show notes. If you're in the chat, exorcism.io. And we beat all of these ones, but they added a new one in the middle. So we'll go back, retroactively take care of this one, and then we'll move on to option. And again, we've done this stuff when we did the book, so some of it's a review, but it's a really nice review, and it's like we've been learning a lot, doing a lot of test-driven development. I'm having fun with it. I hope you're having fun with it. So let's jump in. So we'll go back. We'll take care of this one. So this one's called resistor color. Convert a resistor band's color to its numeric representation and back using external crate. So external crates. Most programs had dependencies on some libraries. Managing those by hand can be a pain. Luckily, the Rust ecosystem comes standard with Cargo, which we've been using the whole time, right? And that helps us manage dependencies for the project. We'll often see external packages being referred to as crates in Rust. A crate is a compilation unit in Rust. Crate can be compiled into a binary or into a library, and we saw that when we did the book. And we used a few crates, right? So go back to this one here. We made an HTTP request using the request crate. So we're familiar with using crates. We've done it before. Definitely check this out if you're interested in making a request to an API. That was a really fun one. But today we'll be going over crates as well. So we're going to click this exercise, and we'll read through the instructions, and then we'll just copy this to get going. It's super easy. All right. If you want to build something using a Raspberry Pi, you'll probably use resistors. For this exercise, you'll need to know 2 things about resistors. Each resistor has a resistance value. Resistors are small. So small, in fact, that if you printed the resistance value on them, it would be hard to read. Interesting. To get around this problem, manufacturers print color-coded bands onto the resistors to denote their resistance value. Each band has a positive and a position and a numeric value. The first 2 bands of a resistor have a simple encoding scheme. Each color maps to a single number. In this exercise, we're going to create a helpful program so that you don't have to remember the values of the bands. These colors are encoded as follows. Black is 0, brown is 1, red is 2, orange 3, yellow 4, and so on. The goal of this exercise is to create a way to look up the numerical value associated with a particular color band, to convert the numerical value into a string representing color, right? So take 9, convert it back into white or something, and to list the different band colors. For test numbers 2 and 3, these 2 here, converting the numerical value into a string and list the different band colors, we'll need external crates enum-iterator and int-enum, which are included in this exercise's cargo.toml. We'll check that out. Be sure to check the crates documentation to learn how to use them. Mnemonics map the colors to the numbers that, when stored as an array, happen to map to their index in the array. Better be right, or your great big values go wrong. All right, so more information on the color encoding resistors can be found in the Electronics Color Code Wikipedia article. Interesting. All right, so let's pull it down. So we basically just copy this. We're going to go over to our terminal. Make that full screen. I'll zoom in there a bit. Clear that out. And we'll paste that code there. It's going to download that value. I'm just going to close. I have a VS Code open there. I'll close that. And so now you should see resistor color. Yep. So we're going to cd into that. Awesome. Let's open that up. And a few folks again were reaching out asking about the theme we're using and how we're getting the type inferences. So we're using Rust Analyzer. We downloaded that into VS Code. Again, you just go to your extensions, and if you just search for Rust Analyzer, it's going to be a little bit better than the Rust built-in because it gives you that type inference and it kind of runs for each project. It's pretty sweet. And then for the color scheme, we're using Greyjack, who joins our chat occasionally. I believe we're using, let me see. Yeah, so Greyjack, we're using One Dark Greyjack, but definitely check out Greyjack's themes. Greyjack hops in the chat from time to time, but these themes are designed to work really well with Rust Analyzer, and I find them way better than the built-in themes. So shout out to Greyjack again. Thank you for that. All right, so let's get rid of that. Let's open up our file thing here. There we go. All right, so let's take a look first at our tests. Again, we're going to work TDD, right? So the first test is a function called test black. Assert equal. So we assert the color to value, giving a color. So we're using an enumeration here. Should be 0. And before we do that, let's take a look at our cargo toml because it mentioned pulling in 2 crates. So this is how the crates get pulled in. They're specified here in the dependencies list of our cargo.toml. If you're not familiar with toml syntax, again, we've been using it for a while. We used it with the book. Anytime we use cargo, we're using it. It stands for Tom's Obvious Markup Language. I'm Tom, but I'm not this Tom. This is a different Tom. Just so happens they chose a cool name, I know. But it's awesome. This is how we're going to specify our dependencies. This is how cargo will be able to install them. So we need to code this color to value. So let's go to our lib. And again, we always have our README that explains how this works. So we can always pull up the README. And so we can see here in the instructions, these are what we just read through on the Exersysm site. So it's also on the website itself. So let's try to get this first test to pass, and then we'll remove these ignores and do a little TDD. So we have our enum, resistor color. We have color to value. It takes a resistor color. It's unimplemented, but we should return its value. So we don't have a map. Currently, we don't have a map between these values and their number. So what we can do is we can implement this kind of naively. We'll just do a match. And then it'll work for our test. We'll get our test passed, but we'll have to iterate. And eventually, we'll probably have a map from color to number. I think that's where we're going to get with the external libraries. But for now, we'll do something super basic. So what we're going to do looks like my code shortcuts, my AutoHotkey got messed up. Let me just reopen that. All right, we should be good now. Perfect. Nope, something's messed up. Let's go back. Okay. Something's messed up with my... That's right, we should be able to... you know what it is? I probably have caps lock on. So let me just close that again really quick. Sometimes if I start my AutoHotkey when I have caps lock on, it really messes stuff up. Let's go back here. Let's exit AutoHotkey. So I'm using AutoHotkey so that I can have some of the kind of like the Vim commands that I use actually in VS Code so that I can use them outside. No? Okay, let's see. Yeah, so my caps lock is on, so that's probably the problem. So let's try this. Sorry about this. Let's do this one more time. Exit. Let's just try typing, make sure we're not on caps lock. Okay, so we have caps lock. There we go. Caps lock is off. And now, if I turn that back on, we should be good to go. Yep, okay, sorry about that. We are back in action. So let's continue. So unimplemented, so we're gonna do a just naive match here. So we'll do match, and we'll match on resistor color. Or sorry, in this case it's color. And if you hover already, it's gonna say We're missing an arm, but that's okay. So we're going to do resistor color black. And if it's black, we will just return 0, which I believe is what we saw in the README. Let's take a look. Black is 0. Yep. And so for anything else, we'll just return 1. Obviously, this isn't correct, and we would probably have a match for each one. But again, it'll work for the first test, and then we'll reiterate. So what I'm going to do is I'm going to run cargo test. And great, our test passed, but of course, subsequent tests are going to fail. So let's go to our subsequent tests. We can see we have orange, white, and if I run these, we'll see that our test fails. Great, so we got it to work for the first one, but in TDD fashion now, our second tests are failing. So let's go ahead and make it work for those tests. So what we really want here is a map. We want a map from resistor color to the value. And we can use a match, so we can continue doing what we're doing. And what that would look like is this. Right, we'd have all of these here prefaced with resistor color. And we could probably just copy this. Right. And this works, but ideally we'd have some sort of map that we could just reference. But for now, let's just do this. We got our test to pass, and then we will iterate. And so what I'm just going to do is just clean this up a bit. Oh. It doesn't want me to do that. Not that, not that. All right, so let's just do this, clean this up a bit. All right, bear with me here. And we're just gonna have to map to basically what we saw in the README. So I'll open up the README, and you can see we have 1, 2, 3, 4, so just down the line here. So brown is 1, blue is 6, green is 5, gray is 8, orange is 3, red is 2, violet would be 7, white is 9, and yellow is 4. And now we've handled all the case, so we can get rid of our default, and it won't complain. And now if we run our tests, they'll pass, but of course this may not be the best way. So what we can do now is we can actually iterate. We have a passing test, so we know that this works. And now we can fall back on that test and try iterating. So let's go back to our docs and let's search Rust map. Well, let's do Rust lang. Not the Call of Duty map. So here we have a map, an iterator that maps over the values iter with f. So we have a map of some type, right? So here we have a vector, 1, 2, 3, converting it into an iterator. So this is mapping over an iterator. So that's not actually what we want. We want like almost like a hash map. So a hash map would be, in this case, could be a map of string to string. In ours, it would be a map of string to int. And we would have to insert those values. So here you can see they have a map of book reviews, and they're inserting, this is the key and this is the value. So we could also use a map. So they also have hash map from, where we have a hash map where we're declaring it like this using a tuple. So this would be a good thing, but we'd have to convert our resistor color, right? We would have to, we could use the enum, but we'd have to create a second value that's basically this hash map, right? And we can do that. We can create it out here somewhere. But let's kind of see what we're going to get into with the other parts of the program, and we'll see if we actually need to do that. Because it would be nice to clean up our map, although it's probably just as much code declaring the map, unless we do an iterator over this enum somehow, over the values, and create the map in a generative way. But for now, we can just use this color to value. This is kind of serving as our map anyway. So we'll continue with this. I'm sure we'll find some better solutions once we submit this, and then we can always re-implement. Okay, so for the next one, value to color string. So convert the value unit type into a string representation of a color. So they're going to give us the value. We need to convert to the color. So we have two libraries we brought in, int-enum and enum-iterator. Enum-iterator is going to iterate over enum. So that's kind of what we were talking about, right? Wanting to iterate over, over our enum, iterate over that so that we can create that value. And then int-enum, I'm not sure what that does, so let's just search it. So we can do that on crates.io. So we go to crates.io and we can search for int-enum. Let me zoom in a little bit for all of you. Int-enum. All right. A procedural macro for conversion between integer and enum types. Pretty cool. Let's see how to use it so we can look at the docs. It's a trait. So check this out. Use int-enum, int-enum. And here we have an enum, small int, 1 equals blank, 2 equals blank. And we just put, let's see, partial equality, int-enum. So we add derive int-enum. And then we can assert 1 equals small int 1 int value. So that's how we get the value from it. All right, so let's try that. So what we're going to do is we're going to use that, just like the docs say, use int-enum. And what are we using from int-enum? We're using int-enum. And we're going to add that here. And now you can see it's complaining because we're not actually doing anything with it, right? And it also says no represent found. So we need to also add this represent trait there. And now it's saying missing discriminant value. So we need to actually make it use this stuff. So we can just use our mapping down here basically. So we do 0, blue equals 6, brown equals 1, green will equal, green will equal 5, gray will equal 8, orange equals 3, orange 3, I wonder, Half-Life 3, confirmed, maybe, equals 2, violet equals 7, white equals 9, and yellow equals 4. And there you go, see it stopped complaining now that they're all written out. So pretty cool. And now we can maybe we can leverage that here, right? So how will we do that? Well, int value. We just want int value. So what we can do is we can match on color. And what if we just, instead of all this, let's comment it out. Well, first, let's run our test to show again that, okay, so we do have a problem here, and that's just because I have to do this, right? If we run cargo test, our test should still pass, right? Oh, our build failed. Required by this bound in int-enum. So we need to require the trait copy. Let's see what else it says. The trait bound register color clone is not satisfied. Trait clone is not implemented for resistor color. Not copy, we want clone. And then now maybe we also need copy? Yes, okay, so we need both clone and copy. So we need those traits so that it can probably work properly. Again, copy is gonna make sure that when it passes a value, it doesn't get borrowed. We're saying that it's gonna, or I'm sorry, clone means, right? It's gonna create a clone of it. So that's what that's gonna do, right? So we should be good now. If we run our tests, let's run our tests. Okay, our test still passed. So now let's go ahead and change that code and make it a lot simpler. Let's comment this out. And let's just do color. And then again, we can do .int value. So color, because again, color is a resistor color. And we can leave the semicolon off because we want it to return. Now, it says here, expected use size found U8. And that's because this is of type U8. What if we convert that to use size? Everything's done complaining. Let's see if it still works. Awesome. Much simpler, right? So it kind of did what we wanted. So we use that int-enum to convert this enum into a representation of integers of type usize. So a little different than the docs, but again, we're dealing with usizes here, so that's great. Now we can get rid of this. You could leave it if you were interested in it, but I think this is more, succinct. So then we run cargo test again and see that our tests, in fact, still pass. Golden. Look how simple. Much nicer. The power of crates, right? That's the power of crates. Little Huey Lewis in the News, Sometimes you gotta do it. All right. Now, value to color string. So we want to go basically the other way, right? So we want to go backwards. So let's see how we can do that. I believe what we want is maybe int-enum has a way backward, and it does. Check it out. From int. So we take resistor color from int and we pass it the int, and we should get the actual color value. So let's try that. So first things first, let's go ahead and uncomment that part of the tests and show that they fail. So let's open our tests. Let's uncomment that. So value to color string, get rid of that. Let's comment this one out too. Let's comment this one out too. And we'll leave this one because this is testing a different function. Test 11 out of range. Oh, it's actually testing value to color string, but let's leave it out for now and we'll come back to it. So I'm going to save that. I'm going to show that these in fact fail. Great. So our 3 failed, and it shows the ones that failed. Test, right? You can see test 6, test 2. These are these ones here, the ones we just uncommented. So let's go ahead and implement that. So we'll go back to our lib. Let's close that out. So here what we're going to do is, let me just make myself a little bit smaller so I'm not in your way. A little better? Okay. Actually, it'd probably be even better. Bam. Out of your way, right? All right, so, whoa, sorry about that. Okay, so what we're gonna do now is we're going to just use the other function that was available on that enum. And so if you remember, what we're gonna do is we're gonna use this here, from int. So we're gonna do resistor color from int. Actually, I don't know if we can use int because we're dealing with usize, but let's see. And value. Let's see what it says. Expected struct string, found enum, result, resistor color. Expected string because the return type string. Sorry, so we want, so if you look at from int, it returns a result. So we need to use either the question mark to kind of force it. And now it's going to say, expected struct string found enum resistor color. So then we can just do, we want to do it as a string. So we can do a few things. We can format it, or we can maybe do, we might be able to just convert it to a string. Let's see, will that not work? Okay, let's try this. Let's do, what if we did let color equal, what is this saying? Let's see, this says the operator can only be used in a function that returns a result or option. I thought this did return a result or option. Let's see. It's saying from int unknown. Let's try this. Hold on. Resistor color. So this one worked. Int value, resistor color from int. Maybe, okay, let's see something here. And then what if we did string, what is type color now? Color is unknown. From int is unknown. Let's see. Here we have I8, U16, try from. We could do that, try from. Because we're not dealing with an int. Let's try that, try from. Okay, let's see what this says. Try from is the trait bound resistor color from usize not satisfied. Required because of the requirements on the implementation of into resistor color for usize. Required because of the requirements of try from usize for resistor color. Required by try from. So let's see. Try from value t, result self error. Let's see what this says here. What if we do? Let's see, try from. The trait bound resistor color is not satisfied, required because of the requirements of implementation. All right, so let's see if we're doing this wrong. Partial equality. Maybe we need to, let's see, does it say that we need to implement some of these? Let's see, maybe we actually do need to implement some of these. Although we're not comparing it, so maybe not. I think that's more probably for the assertions that they're doing below. Although, yeah, maybe it is the case. Seems to work now. Wait, let's go back. I want to see what that error was. Oh, actually. What does it say here? Conflicting implementations of trait partial equality for, oh, because we already have it. Duh. Okay, so let's see. What is this saying? The trait bound resistor color from usize is not satisfied. Required because of the requirements of the implementation of into resistor color for usize. All right, not totally sure. Let's see what it says. What if we did, let me see something. Let's get rid of this for a second. Let's see, what is this? What is the try from resistor color usize? Oh, values usize. Resistor color. So we have try from result self. Into resistor color for usize. Let's take a look here. Let's read through this a little deeper. So we have int-enum. Int-enum. So here they're doing from 8. I'm pretty sure because they can do that because of this. Let me see. From int. Surday supports serialize. Okay, that's for serialization. Try from int. Let's see. What if we did let me see. Let's try something. Let me just try something really quick. What does this say? Result resistor iterator doesn't implement format display, is not implemented for result. So we do have a result, so let's do this. Now it'd say, doesn't implement standard display. Okay, so let's try using, well, we can use just this instead. can only be used in a function that returns a result or option. Obviously, we're not doing that here. So this will actually throw an error if it breaks, but let's try. So we basically just format it as a string. Let's see if that works. All right, so it still failed. Oh, because it got a result. Duh. Okay, so we actually want to do... We actually just want to do let color equals... And so here it's going to complain because we're not explicitly saying that this function can return an error, right? It returns a string. So what we'll want to do is we can actually get rid of this and do a match on this. So we could do, or we could do, I believe it's a let if, is it? Or if let. Something like, oh, we can do an if let, but let's just do a match. And then we'll look up what the if let syntax is. So if we have OK and then some value, right? Then we'll just return the value as the formatted string. And we'll call this color. Otherwise, we'll return just an empty string. All right, so if this works, we'll get OK color and we'll return the color. Otherwise, we'll return an empty string. Let's try that out. And then we can simplify this. We'll use our TDD. So we'll run cargo test. Great. Everything passes. Now let's see how we can make this better. I believe what we want is Rust if let. So an if let is if let some I. Oh, this is more for option. Okay, so not for result. Let me make sure that's the case. Whoa, it's letting me type in here. That's pretty cool. All right, so I think we'll stick with this for now. Let's comment out those other two tests. So in this case, it's testing that 11 is out of range. So if we don't get the value, we want to turn value out of range. So let's just go ahead and run this, and we'll see that our test will fail, and then we'll add this string as our fallback. So we're going to run cargo test. That test fails because it expects it to return value out of range, but we returned an empty string. So all we need to do there is, for this case, return value out of range. And I believe it just expected it, yeah, like that. So now if we run this again, awesome. We're all set. Everything is going good. Now colors. Return a list of all the colors ordered by resistance. So here's our colors. Here's the resistance. We can map over the resistance values by just using a range. But we have this other library here, right? Enum-iterator. So let's take a look at what enum-iterator is. We can go back to crates.io. What up? We got a new follower, Tuna Dinhober. I don't know how to pronounce that, but hope it worked. Hustled X, first time in the chat. Hello, can I ask you a quick question? Of course, anyone in the chat can ask a question as long as it's appropriate and not a bot. All right, so enum-iterator. I believe that is what we are going to use. How do I not get syntax error in Python? It's kind of a general question. A formatter might help you. Some sort of, like I have Rust Analyzer. Maybe there's a Python equivalent. I know there's some really good Python IDEs out there, such as PyCharm. That could probably help with that. But yeah, just Google. If you get a syntax error, usually I just Google it. That's how I do it. All right, so enum-iterator. Tools to iterate over the variance fields of an enum. So we have an enum. We need to iterate over it. Let's go to the docs. All right. So here we have day, right? And there's Monday, Tuesday, Wednesday. So we have the same thing. So they're using into enum-iter.next. So they're iterating over it. So we can do a few things. We can, I guess if we really want to use, we don't actually probably need this. So the way I'm thinking about, I guess if we really want to solve the test is, let's see, the test says all colors. So it's passing it all of these colors, right? And it wants the values. But it's actually supposed to return a list of all colors ordered by resistance. So there needs to be some sorting. So if I look at the test, it's checking it in the right order. That's great. But I think, let me just try this without the crate and then we'll bring in the crate, because I think they do want us to get experience with the crate, but I just have an idea. What if we just did 0, just do a range, right? So 0, so create a vector from 0 to, what is it? No, I believe this is inclusive to 9, right? And what if we just mapped over that and we got the value? And what if we just returned, what did we want? What is the return type? Vector resistor color. So we actually want the resistor color. Okay, I think that's why. Although this actually should work. So what if we did, yeah, what if we just did resistor color? Well, I guess we don't want the color string, but from value. What does map say here? Method map exists for struct, vector. Trait bounds were not satisfied. Mismatch type expected vector resistor color found struct range integer. Oh, because okay, so we do need to create a vector from this. All right, so I think we'll probably have to loop over it because it's expecting a vector of resistor color. So let's do it. So we have into enumerator. So let's pull that in. And how do we use it? We add it to our enum. And then we can enumerate over it. So direction into enum-iterator. And then that's just going to create a vector of our enums. So let's do that. And we'll return that first to show that it's actually not going to work. But so because it's not going to be ordered, right? So we'll do into enum-iter. Save that. And what does this say? Expected struct vector resistor color found resistor color enumerator. So we need to convert it into a vector. So let's see if there's a way to do that. Maybe just dot collect. So what dot collect does is it collects it into an actual vector. We can specify the type, but it can infer it. So let's see if this actually, it's not going to work because they're not going to be in order. Oh, wait, are they? Did I not comment? I didn't unignore it. So let me just unignore it. It's not going to work because they're not going to be in order, but let's just see what happens. Running it. So it failed, but check it out. It's just because they're not in order, but we did pretty good. So now we need to sort them. And so the way we can do that is we can create a sorter, or we can just change the order of our enum so that it's in order, which would actually also work. I think, though, to be better about it, we should try sorting it. So let's look up how to sort. So sorting a vector Rust cookbook. Vector.sort. I think there's probably a default implementation of what sort is. I think it's going to use partially quality. So let's just try doing that way. And so collect here is complaining because, we probably want to move our sort up. That's why. And let's see what sort says. No method name sort found for struct resistor color enumerator. And that's because we need to sort over a vector. So let's see what collect is going to give us here. From iterator, we have an iterator. Take anything iterable and turn it into a relevant collection. The most basic pattern in which collect is used is turn one collection into another. You can take a collection called iterator on it and do a bunch of transformations, then collect at the end. So let's see why it wasn't letting us call sort. So this here says type annotations needed. Because we're trying to sort. So what are we collecting it as? We're collecting as a vector of type resistor color. And need to do that. So now let's see what's complaining about. Expected struct vector resistor color found the unit type. And that's because, let's see, what is sort doing here? Let's see here. Let's get rid of some of this. So here we have the iterator. And let's see, can we just actually do a sort on the iterator? Let's see why it's not going to let us do that. So there's no sort method on that, but we can actually do here, you can see in our, let me go back here. And we're calling enum-iterator, which is going to return us an iterator. And now we want to sort that iterator. So let's see. Let's search specifically for rustlang sort iterator. Collect sorted. Let's take a look at that. That could be promising. Rustlang sort iterator. So we know that collect, so let's try this again. So collect is going to give us a vector. And I think we need to specify the type. So let's take a look at vector collect. Let's look at the docs. Should be here. Sorry, it's actually iterator collect, right? So let's go back. Collect. Transforms an iterator into a collection. Collect can take anything iterable and turn it into a relevant collection. So here they're not specifying the type, but we can actually specify the type like this, vector of type. So if we say that we're collecting this into a vector of, and of course we need to include this, right, so that should work. We should still fail, which is fine, but it's because it's not ordered, and now we just want to order it. So if we did dot sort, and sort is complaining because why? Expected struct vector resist color found unit type because the return type. So sort. So sort doesn't in place sort. So maybe we actually just have to do Why is the return type of sort? Let's take a look at it. Sort. So sort. Here we go. The trait bound resistor color OR does not satisfy. The trait OR is not implemented for resistor color. So maybe we need to implement OR. What does it say? Partial OR. And what does this say now? Found unit type. What is it saying? Let's see. Sort. Expected. Because the return type. This sort is stable. Does not reorder equal elements. Okay. And let's see. Why is the return type the unit type? What if we did and return sorted? What is it saying? Is the unit type. So what if we did collected equals collect? So we're going to just collect that. And then if we return collected, that's the same. And if we try to sort collected, it's going to be the unit type. So let's make this mutable. Sort it and return collected. And it's not complaining now, but let's see if that actually works. All right, that works. Now let's see why that is. Let's see if we can just do so it looks like sort does return the unit type because it actually just mutates it in place. And so we need to explicitly return it at the end. So we declare it mutable. We get a vector by using collect. That's what we're doing here. Oh, sorry. Scroller. We get a vector by using collect, and I can leave this off because it knows the type. It can infer the type. Actually, it can't. When you use sort, it needs to know the type. So we put the type there. We're explicitly saying, hey, we have a vector of resistor color. We're going to inline sort it, and then we're going to return collected. And I believe all of our tests are passing. So let's run it again, make sure. So everything passes. So now what we can do is we can submit this exercise and see what happens. And we can try to iterate on it. We can see how other people have solved it. But let's quickly go over now that all our tests are passing and see if there's anything we would like to change. So first things first, this looks really great. We're using that there. That looks great. This one. So for this one, we are using a match statement. We could have used the question mark, right? And just like caught the error. But this is pretty clear. It's like, hey, if we match on this, if we get the color, return the color. Otherwise, return out of range. So pretty straightforward. The other thing we're doing here is our colors, where we iterate over it, we collect it, and we sort it. Again, we could have just sorted this list, but I like that we're explicitly sorting. I think that's much better, right? Because then we can add to this and not have to worry about the ordering. All right, let's submit it. So the way we do that is we do exorcism submit the lib file. And we can view our solution. How do I do it? There we go. So we go over to our Rust, just refresh that. It's processing our solution. We can see our iterations. And it's probably taking a little longer to process than before because of the external crates, I imagine. But it's going to run the tests. Oh, and it says it failed. Let's see why. Let's go back. Oh, it's still processing. Failed. Please check the test pass locally. All right, let's check again. They definitely pass for us. Let's see if it's something funny that we submitted the wrong thing, maybe. And we've commented all of these out. Let's run it again. What was that? Yeah, they pass locally. Let's try it again. I wonder if it has to do with... Let's see if we can see how the test failed. They timed out with an issue in our infrastructure. Or the code is running slowly, or there's an infinite loop or something similar. I don't think there's an infinite loop anywhere. And the code is working for us. Let's see how other folks have done it. Maybe we did something silly. So we can go by stars, kind of see. I don't see a lot of stars on any of these. Again, this is also a newer one. Let's just take a look at the latest one here. So same thing we did. So they did a little different into value into, that's to convert it because they used U8 and converted it into a U size. Here they're doing value as U size, mapping over it, unwrapping it. We did a match, and then here they're doing into-iterator collect, but again, they've ordered them here. We didn't, we're sorting. So that's a slight difference. Let's see what this folk's doing. So same thing we did here, color into value, great. They have the same thing here, exactly the match statement. And same thing here, but again, they're not sorting because they've ordered it here, whereas we actually are sorting. We can try not sorting and seeing if that passes the test. I mean, we could do it that way. I kind of like our solution better, to be honest. Let's try it and see if that's what makes the test pass. That'd be weird, but worth the shot, right? But yeah, I kind of like our version better where we actually sort it, right? To make sure. This way you can add and not have to think about where you're putting these things. But yeah, let's give it a shot. I don't know if that's what's causing our test to fail. Again, it's running locally, so maybe our sorting is taking a while. Maybe it's slow. It didn't feel slow to me. Okay, so then what we would just do is just get rid of this. We don't even need this, right? And we're no longer sorting, so we don't need to declare the type. And cargo test. And we're all good. So let's go ahead and exorcism submit and see if they like that better. Processing. Could be the infrastructure. Maybe they're running on AWS. Big AWS outage today. I don't know. Either way, I like our old iteration. So if this doesn't pass, yeah, so this is weird because we have the same thing that everyone else has. Strange. I don't know. Yeah, they timed out. Weird. Let's come back to this. I feel like they shouldn't be failing. But who knows? What do I know? Yeah, so I'm going to dig in a little bit. I'll try to figure out why that's failing. But, I mean, yeah, it's working locally. Everything seems to be good. Again, if we run cargo test, we see that all 8 pass. It runs relatively quickly. Maybe it's something we added. Like, maybe we didn't, we don't need these now. But, and again, we have tester in development, so we can run it, see that it works, and yeah. I'm not sure why that's, maybe I submitted the wrong path. Let's see it. No, submit source lib. That's correct. Yeah, I'm not sure. Maybe we'll have to come back and check. It's a weird one. But yeah, pretty cool. Got to see some external crates. I don't know why that's not passing. It's passing locally. And like they said, it does say here, it could be an issue with their infrastructure, but more likely suggests that your code's running slowly. Is there an infinite loop or something similar? I don't see anything. I think our solution looks very similar, if not equivalent to, this solution here. I think we have the exact same solution with the difference that, actually, no, we have the exact same solution as this person. So even to the point where they have usize. And we have int-enum-iterator. Yep, int-enum, copy, clone, equality, partially. Yeah, so I'm not really sure what could be happening there. Well, we'll check back. I'll check back and see if that actually runs. That's going to be it for today. Sorry, it was a bit of a shorter session, but we'll be coming back again next week, and we'll be picking up with options. So we'll continue the syllabus. I'll keep retrying to see if this test passes, but we'll pick up next week with option. Sorry we didn't get to that today, but it's been fun. Thank you for stopping by. Check back next week for option, and we'll try to get through a few other ones. We'll start a little bit early to get through those. But yeah, thanks for watching. Again, if you're watching on YouTube, really appreciate it. It's been awesome to see people joining. As always, love to see it. If you're enjoying these videos, let me know in the comments section. If you're enjoying the exorcism, if you tried it out on your own, let me know how it's going for you. If you've tried any other tracks, let me know how it's going. If you're interested in seeing me try some other tracks, down for that as well. I mentioned in the past I've been doing a lot with Elixir, so I'd be happy to show some of that stuff, although I'm really enjoying this Rust journey, so probably going to continue. Again, if you missed any of the previous videos, check them out on YouTube. We have part 1, part 2, and we'll be continuing with these exercises. We have, after we complete the syllabus, don't worry, there's still plenty of exercises that don't actually map to the syllabus, but are really fun. Look at this. Shout out to the exorcism.io community for creating these, and they're also ranked on how hard they are. We'll just keep going through these. And it may be like, okay, why don't we build something, exercises, whatever. These are what are going to get us to kind of see some of the use cases, and you can see they're kind of geared towards real life scenarios, right? And also it's getting that memory. I feel like with Rust, more so than any other language I've used, I need to continue using it so I don't forget and really stretch those muscles and get a feel for the language. It's a tough language in my opinion. And I've used a lot of languages, but it's such a powerful language. And once you do, I am starting to get to the point where it's becoming a lot easier, and I'm able to reuse some stuff. And you can kind of cut out some of the stuff the book has you do some stuff the hard way, and you can kind of jump right to the easier way. For example, dealing with results with match statements, or using the question mark to just throw the error. So really cool. Stick around. We'll be back next week. Hope you enjoyed that. We'll continue with this. Sorry again for the shorter episode this time around, but don't worry. We'll be picking it back up and doing a lot more Rust. Thanks again for stopping by, and have an awesome night.